Today, there are at least 4 pressing mysteries that physics still needs to solve. Humans have always wanted to fly, but it's always seemed impossible. The ancient Greeks told the myth of Daedalus and his son Icarus, who constructed wings of feathers and wax and flew away from the tower in which they were imprisoned. But that was just a myth. Around 1500 CE, Leonardo da Vinci constructed several contraptions made of wood in which he hoped humans could fly, but they didn't work. Obviously, there was a physics problem that needed solving. It wasn't until Dutch mathematician Daniel Bernoulli, some 200 years after Leonardo, solved the problem of how a wing should work. The Bernoulli principle of air pressure difference between the curved top of the wing and the straight bottom of the wing. So now, humans first possessed the knowledge of how to fly. But it still took almost another 200 years after Bernoulli for the Wright brothers to actually construct the first motorized airplane in 1903. Before we can travel to the stars, we need to solve some mind-boggling physics problems. As things stand now, we certainly can't accomplish interstellar travel by going in rocket ships propelled by chemical combustion. There are 2 reasons why it's just as crazy to try to fly to the stars by rocket ship as it is to try to swim across the Pacific Ocean. First, the stars are too far away, and second, our rockets are too slow. Even light speed is too slow. It takes light about 4 years just to get to the star closest to the sun. It would take a modern rocket ship tens of thousands of years to reach Alpha and/or Beta Centauri. Forget about it. Obviously, science has several challenging physics problems that still need to be solved before we'll ever be able to travel to the stars. But it can be done. First, the mystery of space itself must be solved. The question, what is space, is presently the biggest mystery in physics. Well, it seems like a very basic question, but even simple questions are very important. Like, what's for dinner? Ugh, not meatloaf again. Some progress has been made in the last 100 years to find out what space really is. Albert Einstein showed us, with his theory of special relativity in 1905, that space is not just space, it's also time. Einstein showed that space and time are one thing. You are here now, and I am here now, in a relatively different space-time. It was the Lithuanian-German mathematician Hermann Minkowski, Einstein's math professor in Zurich, Switzerland, who coined the famous term, the space-time continuum. So now, we don't just have space anymore. Space is gone. What we have instead is space-time. The two are bonded into a continuum. Space and time are now a 4-dimensional entity, sometimes called Minkowski space, which can be represented geometrically as a light cone. So let the here and now in the center of the light cone be the Milky Way. The past is the only part that we can see. We only see things as they were when they sent us the light that we can see coming from them. But as we move forward into the future, our horizon of light expands and we can see more. So what is over here outside the light cone? We don't know, but there could be lots of things. We're just starting to get our foot in the door, but we're going to pry it open someday. 10 years after he published his special theory of relativity, Einstein published his general theory of relativity, in which he showed that space-time becomes warped in the presence of gravity. This became the next step forward. Suddenly, gravity as a force was gone. Now we have the gravity field, and it warps in the presence of mass. If space-time can warp in the presence of gravitational mass, can space-time break? And if space-time can break or rupture, what's on the other side? With these questions, black holes suddenly became the second mind-boggling problem for physics to solve. The study of black holes, a term coined by John Wheeler in 1967, a former co-worker of Einstein in Princeton, New Jersey's Institute for Advanced Study, became a preoccupation for modern physicists because black holes appear to rupture space-time and open up a 5th dimension. And if there are 5 dimensions, there could be more. Black holes are found in nature at galactic centers, where orbiting gas and light are accelerated by gravity to speeds beyond the speed of light. Since nothing can travel beyond the speed of light in this universe, could black holes lead to other universes? Fortunately, we don't have to go to the center of the Milky Way to study black holes. We can make them in a laboratory, right here on Earth. And what a laboratory it is! The Large Hadron Collider, LHC, in Europe is a circular 16.7-mile-long underground laboratory designed to explore subatomic spacetime and the particles that inhabit it. The LHC is the largest machine ever constructed. So what does the Large Hadron Collider do? It smashes things, like protons and other particles that can be accelerated by the miles of underground electromagnets. After powerfully accelerating them to nearly the speed of light, these particles collide into heavy atomic nuclei, like gold for example. The bombarded nuclei then shatter into a multiplicity of smaller fundamental particles that protons and neutrons are made of, quarks of all kinds, colors, and flavors. And no, there aren't any chocolate-flavored quarks. Quantum physics is the study of matter and energy at these most fundamental levels. Now, with the Large Hadron Collider undergoing an upgrade, which will make it even more powerful, black holes will be able to be observed forming during these quantum-level collisions. These black holes will be teeny tiny, itsy-bitsy, quantum-sized. They're only expected to exist for a fraction of a second before dissipating. Scientists at CERN in Switzerland assure us that the black holes that they make will not fall through the floor and go to the center of the Earth and begin swallowing the planet. And that's a very good thing to know. The upgrade to the Large Hadron Collider will be completed between 2025 and 2027. It's part of our need to find out what space-time is, or else we might just be stuck on this little planet Earth without ever being able to explore the universe. Time is part of the mystery of space too. After all, it is called space-time. The mystery of time has been difficult to crack. However, exciting progress has been and is being made. Once upon a time, as the story goes, Albert Einstein was giving a lecture about the speed of light. In his famous formula, E equals mc squared, the letter c stands for constant, because the speed of light is a universal constant of space. A student raised his hand and asked Einstein, "But doesn't light go slower through a glass of water?" Instantly, Einstein realized he had always focused his attention on how fast light goes, and never seriously considered how slow light can go. Together with his colleague, mathematician Satyendra Bose, they calculated in the early 1920s how dense of a translucent material it would take to stop light. The material became known as the Einstein-Bose condensate, but no one believed it could ever be created in a laboratory, until it was done in the 1990s. Dr. Lena Vestigard Howe of Harvard University created an Einstein-Bose condensate by supercooling atoms of sodium gas down to a billionth of 1 degree above absolute zero. That's the coldest anything can get. It's even colder than my bedroom during the winter. At this temperature, the atoms of the sodium cloud bond together and begin acting as one big atom. Space-time in an Einstein-Bose condensate takes on a completely new form that no one has ever seen before. Finally, by the use of quantum-sized technology, science was getting its hands on the fundamental structure of space-time. Inside the EBC, light stopped, time stopped, and physical atoms were able to be teleported instantly to other locations. All of these breakthroughs are only in the laboratory stage of development, which leads to the next problem physics must solve in order to bring these theoretical and technical advances out of the laboratory and into the real world of our social and political lives. That problem is energy. At present, civilization doesn't have a powerful enough, safe enough, or convenient enough source of energy to realize the construction, manufacture, and distribution of the advanced quantum technology that's required to do all the amazing things that we see now are entirely possible, including interstellar travel. But nature has the energy we need: stars. The force that binds the nucleus of atoms together is called the strong force. It's the mother lode of energy in the universe. Stars release this energy when, by their immense internal gravity, they implode hydrogen atoms. This is called nuclear fusion. Modern civilization doesn't have a nuclear fusion reactor that can do that yet. We, of course, do have the H-bomb, which releases the strong force from the implosion of atomic nuclei. But the H-bomb is not a particularly convenient source of energy to use, is it? Developed countries have many nuclear reactors that produce electricity from the strong force by breaking apart the nucleus of the large unstable atoms of radioactive plutonium. These are atomic fission reactors, and they have proven to be, well, not safe. Nuclear fission reactors must be phased out of operation as soon as possible. The race to build a working nuclear fusion reactor faces many technical and economic obstacles. The ITER reactor, presently being constructed in southern France, is an international project that uses the Russian tokamak design of a giant donut-shaped deuterium plasma. A consortium of 35 countries is involved in the ITER project, and they've already been at work on it for 35 years. Some 30 other fusion reactor projects, with various designs, are also under construction in several countries, with none of them yet achieving either a sustained reaction or net energy output. How long can the world hold its breath waiting for fusion energy? Now that's what I call a burning question.
The dark days are mysterious natural phenomena that have occurred only a few times in the history of humankind. We can write them off as eclipses or just some weather events, but in reality, they're very creepy and we have no idea why they happen. So, what are these dark days anyway? What's so strange about them? Let's try to find out. The sun is off. What are we gonna do? That's what the residents of Yamal, Siberia asked meteorologists on September 18, 1938. In the morning, instead of going to work, they all gathered at the weather station. They were waiting for answers. All because on that day, they observed something inexplicable, an eclipse which they later nicknamed the Black Day. And neither astronomers nor meteorologists can explain what happened back then. Here's how one of them described this event. At 8:30 a.m., we noted a decrease in light. At the same time, the color of the clouds began to acquire a yellowish-brown, sometimes red-brown hue. By 9 a.m., the lighting had changed dramatically. It was as if you were looking at the world through a dark light filter. The brown tones of the clouds intensified. By 10:30 a.m., the sky and earth didn't differ from each other in lighting and color. Everything seemed homogeneous, black, absolutely devoid of light. Pretty creepy, right? And that's not all. The city was also plunged into complete radio silence. Meteorologists couldn't even contact the authorities, and local residents were unable to set up any stations. Everyone was in the dark, both literally and figuratively. Meteorologists decided to try and launch several flares. The flares soared into the air towards the heavy dark clouds hanging over the city and disappeared. The clouds were so dense that the flares were completely invisible. At the same time, the weather was perfectly fine. Everything was quiet. And this black silence lasted for about an hour. After that, the Black Day ended as unexpectedly as it began. Even more baffling, those strange clouds left literally no trace. No rain, no dust, nothing. After that event, researchers found out that the Black Day had spread for 125 to 155 miles around. They also learned that the dark band was moving from west to east. After passing through the southern part of the Yamal Peninsula, it headed on for a while and then disappeared completely. Yamal isn't the only place where this phenomenon occurred. In fact, similar eclipses have been happening in different parts of Earth for many years. For example, in New England, on May 19, 1780, people there witnessed an event that was later called New England's Dark Day, but it lasted not one day, but several. A few days before this event, the sky turned yellow, and on May 19th, in broad daylight, it suddenly turned black. Here's what one of the witnesses, Joseph Plum Martin, later told the press. It was very dark. People had to light candles in their houses to carry on with their usual business. The night was as uncommonly dark as the day was. The smell of soot reigned in the air. Nearby rivers were covered with a thin layer of ash. When the real night came, people noticed through the clouds that the moon had turned dark red. Only a couple of days later, people were finally able to see stars through the veil of clouds. And then everything suddenly returned to normal. No one had any idea what had happened. 22 years later, on June 2, 1802, a schooner named El Dorado sailed across the Pacific Ocean. Suddenly, they were overtaken by complete darkness. There was no storm, and the ocean was completely calm, but the whole sky was covered with black clouds. These clouds dissipated after half an hour and left no trace. And again, 74 years later, one of the dark waves happened in Wisconsin on March 19, 1886. It was 3 p.m., and this time, the wave was very short. It lasted only 5 to 10 minutes. A sudden night fell on the city. Frightened horses were neighing, and terrified people were running around, trying to find a place to hide. When everything calmed down, local newspapers reported that the wave passed from west to east. There was no solar eclipse, no winds or hurricanes, nothing that could cause the darkness over the city. And finally, once again, it happened on December 2nd, 1904, in Memphis. Or rather, that's what rumors claim, since there's no scientific evidence of this event. It was clear and cold dawn over Bluff City. People were doing their usual Friday morning chores. Then, around 9 in the morning, without any warning, the sun suddenly disappeared from the sky. It took only a minute for the bright sunny day to turn into pitch darkness. People interrupted their work, and children in schools were completely terrified. And just like in previous cases, the weather was perfectly calm. It lasted for about half an hour and then suddenly ended. A little later, following a mysterious eclipse, a ferocious storm hit the city. So, what's going on? All these strange cases can surely be explained scientifically, right? Well, actually, scientists don't have a definite answer. All these events are very similar, but we don't have a single explanation that could cover them all. Let's take a look at some theories. The first thought that comes to mind, it's probably a partial or total eclipse. But no, this is not the case. There were no eclipses on those days, and even if we consider this theory, before any eclipse, the sky darkens gradually. Eclipses themselves only last a couple of minutes. Certainly not a few hours or even days. Also, unlike eclipses, these events were local to specific cities. Well, maybe it's some other astronomical event. Some scientists believe that during the event on Yamal, a band of cosmic dust touched Earth, but later they found out that no astronomical bodies approached the planet that day. Alright, any other ideas? Forest fires could be the reason. When a large area of forest is burning at the same time, a column of air can rise to great heights, like 3 to 4 miles. These airflows carry ash and other burnt stuff to different places, and since all these things are so high in the sky, they simply freeze there and turn into something resembling black clouds. That was probably the case for New England. At that time, a wave of forest fires broke out in Canada. They could easily spread through the north of the US. Also, just look at this description. Yellowed sky, the smell of soot, ash on the water. Everything sounds logical, but this theory of fires only works for the event in New England. What about the other cases? Where would you find a forest fire in the middle of the Pacific Ocean, for example? Alright, moving on. Scientists tried to explain the story from Memphis by saying it could be a hurricane, but the black cloud swept through the city before the storm, not during or after it. And it wasn't some kind of typical storm cloud, it was full-fledged night darkness. So what's really going on? Now, meteorologists call this phenomenon a local decrease in the transparency of the atmosphere. Unlike solar eclipses, this darkness is denser. It also covers only a small area. The transparency of the atmosphere is its ability to let through radiation and light. It's basically, how well can I see distant objects? Everything can get dark and blurry, for example, because of the dust in the air, volcanic eruptions, fogs, and so on. So, according to this theory, dark days are just an extreme drop in the transparency of the atmosphere. But it's still strange. If that's the case, shouldn't everything have been covered with thick fog or something like that? Yeah, it was very dark, but when people lit the lamps, the visibility was pretty good. Nothing blocked the view except the black clouds that covered the sun. In other words, this phenomenon is very hard to explain. As far as we know, it happened only 5 to 6 times in the history of humankind. If there were other cases, they weren't documented. This phenomenon is impossible to predict, and no one knows how it works, as well as where and when it will happen next time. And although there are many hypotheses, none of them can be verified. Maybe if these events happen again in the future, we'll be able to study them better. But unfortunately, at the moment, the dark days remain a mystery. Do you have any theories or ideas on this stuff? If so, write them down in the comments.
Thousands of strange spaceships sneak into Earth's airspace. They descend to our planet and fly through cities, plunging people into complete chaos. Suddenly, the door of the largest ship opens, and a strange creature comes out. It tries to copy our language and says they had come from a distant star, Proxima Centauri. Something like this might happen because scientists have recently picked up a strange radio signal off that star. Proxima Centauri is the closest star to our solar system. It's only 4.2 light years away. That means a beam of light that starts from this star reaches Earth in 4.2 years. That's also 270,000 distances from Earth to the Sun. The star Proxima Centauri itself is too pale for us to see with the unaided eye in the night sky. But its system hides a little secret. Let's fly there and take a closer look. So here's this red dwarf. It's 7 times smaller than our Sun and 8 times lighter. Proxima Centauri is 1.5 times bigger than Jupiter and almost 150 times heavier. But what we're looking for is a little further away. This is Proxima Centauri b, a planet similar to Earth. It's only 10% larger than Earth and is in the habitable zone of the star. It's the perfect distance, not too far away and not too close. So the temperature isn't too high or low there either. Water, if it exists on that planet, can be in a liquid state. And so, life can survive and evolve there. Maybe it's developed enough to send us the signal that we had received. A radio signal is basically waves. They have a certain frequency and length, and we can always tell an artificial signal from a naturally generated one. The signal that we picked up from Proxima Centauri b had a frequency of 982 megahertz. The regular radio we listen to in the kitchen or in the car picks up signals around 100 megahertz. That's why scientists have concluded that the signal was created artificially. Such signals could have a way of communication between the developed worlds. If this is really a message from an outer space civilian, we should be able to decode it. For this, any civilization must use the simplest method of encryption. For example, Earth has already sent a radio signal into space. It was the Arecibo message. This message consists of 1,679 digits. It's a rectangle of 23 by 73 squares that has information about our civilization encoded using a binary code. At the top of the rectangle, there's a system of numbers that we use. They're marked in white. This purple thing is the key to read the next part of the message. The atomic numbers of the elements like hydrogen, carbon, nitrogen, oxygen, and phosphorus are encoded in this key. These are the key elements that can start life. If those who receive this signal can make sense of the numbers in the key, they can read the next part of the message. These green things are the building blocks of our DNA chain. And right at the bottom here is the DNA chain itself. The white rectangle indicates the number of pairs of these building blocks, and the blue spirals show the shape of a DNA chain. And then we see the human silhouette itself. The white and blue object to its left is a coded number of our average height. The human itself is drawn here at the ends of the DNA strand, so that the outer space civilization can understand what we look like. And the white rectangle to the right of the human sketch is the number of Earth's population at the time of the message. That's 4.2 billion as of 1974, almost half the number we have now. The next part is a drawing of our solar system. The big yellow square is the sun. Then come all the planets in our solar system, including Pluto. Earth is shifted up a bit here, so that outer space civilization can understand where this message is coming from. In the last drawing is the observatory from which this message had been sent into space. This signal is now on its way to the M13 star cluster 25,000 light-years away from Earth, so it won't get there for another 25,000 years. And we'll need another 25 to get a response if there is really someone on the other side who can receive the signal. If the signal from Proxima Centauri is also a message, we'll need time to decode it. So let's fire up our super-powered computing machine and wait for the result. But this isn't the first mystery signal we've ever picked up on Earth. Scientists recorded an unusual wow signal in 1977. They supposed it came from somewhere in the constellation of Sagittarius. The telescope was picking up the unknown signal for an impressive 72 seconds. Later, a scientist who looked at the printout of the signal concluded that the signal was artificial. He wrote, "Wow," on the printout as his reaction. The following observations and studies couldn't catch this signal again. Some theories said that this signal came from a celestial spaceship flying by. It had flown away, and we could no longer detect the signal. But most likely, this signal was created on Earth. It was directed upward but reflected off an object at a high altitude. It could have been an airplane, a satellite, or space debris orbiting our planet. Then the signal was picked up by the telescope, and because it was human-made, all of its characteristics, like wavelength and frequency, could have confused scientists. In 2017, scientists recorded a flare on Proxima Centauri. The star's brightness increased by 1,000 times in just 10 seconds. Before that, there was another flare there that was weaker but lasted about 2 minutes. With these flares, Proxima Centauri has emitted enormous amounts of radiation. Even if there was life on the star's companion planet, these flares would have likely destroyed it. The stellar winds would have simply blown the atmosphere off the planet and made its surface lifeless. Overall, the planet Proxima Centauri b receives 60 times more high-energy radiation and 400 times more X-ray radiation than Earth. Scientists have concluded that the probability of life here is 1 to 100 million. And while we don't know yet for sure if the signal was artificial or natural, the scenario of a bunch of spaceships coming to Earth is most likely possible. Our only method for searching for outer space civilizations is using radio waves. They're like loud noise that blasts away from our planet in different directions at the speed of light. The main problem here is the gigantic distances. Our galaxy, the Milky Way, is 100,000 light-years wide. Suppose there's life at the other end of it. If we send a radio signal to them, it won't reach that supposed planet for another 100,000 years. And we won't get a response for another 100,000 years. It's the same if someone once wanted to contact us. We didn't learn how to create and receive radio signals until the 19th century. If a civilization was developing at the same time as us somewhere in the Milky Way and they invented the radio, we won't get their signal for several millennia. Plus, the radio noise from our planet is starting to fade away. We use Bluetooth, fiber optics, cable TV. So in about 100 years, we'll no longer be visible to other worlds. Or worse, what if there was an outer space civilization somewhere that was sending signals into space? The signals were reaching our planet, but we didn't yet have the technology to pick them up. The world that was sending the signal has evolved, and the signal went out. We could have caught those remnants of the radio waves that were moving through the universe, but we set up the antennas too late. There are about 2 trillion galaxies in the universe. Each of them contains billions and trillions of stars similar to our sun. Maybe there's a planet near one of them that looks like ours. Life could be blooming there. And this outer space civilization, just like us, is looking through telescopes in hopes to catch the radio signal from an unknown planet.